Hello everyone, welcome to my YouTube channel. Myself Kailash Kumar. Today we'll start with a new topic, sorting with style, the art of insertion sort. Let's move to the next slide. Content. Today we will learn in this topic what is insertion sort, how does insertion sort works, time complexity of insertion sorts, advantage of insertion sort, disadvantage of insertion sort versus merge sort, insertion sort versus quick sort, application of insertion sort implementation, conclusion. Let's move to the next slide. Let's start what is insertion sort. Insertion sort is a simple sorting algorithm that works by repeatedly inserting the next element in a sorted sequence. It is a initially algorithm for small data set and is often used as part of more complex algorithm. It is having a small data set and having a part of a more complex algorithm. The basic idea behind insertion sort is to divide the input list into two parts. Insertion sort having a two parts, the sorted part and the unsorted part. Now the sorted part. The sorted part starts with the first element of the list and the unsorted part contains the rest of element. The sorted part is having a first element of a list and the unsorted part containing the rest of the element. The algorithm that integrates through the unsorted part one element at a time and insert each element into its proper place in the sorted part of the list. The algorithm that in the unsorted parts having in one element at a time and insert each element into a proper place. Let's move to the next slide. How does insertion sorts work? In this we will learn how insertion sorts work. Insertion sorts is a simple sorting of algorithm that builds the final sort array one at a time. It builds the final sort array one at a time. It is much less efficient on large list than more advantage algorithms such as quicksort, heap sort or merge sort. It is more advantage than quicksort, heap sort and merge sort. However, insertion sort provides several advantages including simplicity and efficiency when dealing with small lists. The algorithm works by integrating through an array of items from left to right. Its work on an array item from left to right. For each item, it's compare it to the item that come before it in the array. If the current item is smaller than the previous item, it's moved to the current position in the sorted part of the array. It's moved to the current position in a sorted part of the array. This process continues until all the items in an array are sorted. It's continue all the items when array is sorted. Next, move to the next slide. Time complexity of insertion sort. We will learn in this time complexity of insertion sort. Insertion sorts is a efficient sorting algorithm that works by comparing each element in a list to the element before it and inserting it into the current position. It means that the algorithm that works by comparing each element having and inserting it into the correct position. The time complexity of insertion sort is O n into 2. Having an current complexity of an insertion sort is O n into 2, which means that the number of operations required to sort a list increasing quantitatively with the size of the list. When compared to the other sorting algorithm such as merge sort or quick sort, insertion sorts having a higher time complexity. Then compare of in other element like merge sort or a quick sort, the insertion sort having an higher complexity. However, insertion sort is often faster when sorting small list or a list that are already partially sorted. It having an insertion sort faster than the small list or list that are already partially sorted. This is because the number of operations required to be sorted a small or a partially sorted list is much smaller than the number of operations required to sorted a large unsorted list. It's having a small partially sorted list is much smaller than the number of operations requiring to a sorted large. Let's move to the next slide. Advantage of insertion sort. One of the main advantage of using insertion sort is its simplicity. Its main advantage of insertion sort is using of its simplicity. Unlike other sorting algorithms such as merge sort or quick sort, it is more than other merge sort or a quick sort. Insertion sort is easy to understand and implement. The insertion sort is more implemented than other sorts. It is great choice for small data set or when memory used is implemented. It's having a small data set or when memory usage is implemented. Other advantage of insertion sort is its efficiency when dealing with data that is already partially sorted. In such case, insertion sorts can perform much faster than other sorting algorithm. Insertion sort can perform much faster than the other algorithm. For example, image you have a list of a name in alphabet order and you want to add a new name to the list. For example, we having an alphabet that which contains a new name to the list. Using insertion sort would be much faster than using another algorithm to sort the entire list again. We will check the insertion sort is very much faster than the other algorithm, which is very easy than the other algorithm like quick sorts and the merge sort. Let's move to the next slide. Disadvantage of insertion sort. While insertion sort is a simple and efficient algorithm for small data set, it's become less partially as the size of the data set grow. It is less partially as the size of the data set grow. This is because the time complexity of the insertion sort is O n into 2. We learned before slide the time complexity of insertion sorts is O n into 2, which means that the number of compressions and the swap required grow exponentially with the size of the dataset. In contrast, more advanced sorting algorithms like merge sort and quick sort have a time complexity of O n log n and are better suited for large dataset. Another disadvantage of insertion sort is that it is an in-place sorting algorithm, which means that it requires only a constant amount of additional memory to sort the dataset. It's having a constant amount of an additional memory to sort the dataset. However, this also means that the original order of the dataset is lost during the sorting process, which may not be desirable in certain applications. Now move to the next slide. Insertion sort versus merge sort. Insertion sort and merge sorts are two popular sorting algorithms that have different approach to sorting data. It having both different approach to the sorting data. Insertion sorts works by taking each element in the list and inserting it into its proper place in a sorted sublist. This process is repeated until the entire list is sorted. The process is repeated until the entire list is sorted. Merge sorts, on the other hand, divided the list into a smaller sublist, sorts those sublists. It is divided into smaller sublists and it's sorted through those sublists and then merged them back together to form a sorted list. It's merged them back together to form a sorted list. While insertion sort is best for small lists or lists that are already partially sorted. It is best for only small lists or a list that are already partially sorted. Merge sort is more efficient for larger lists and can handle unsorted data more efficiently. Next, move to the next slide. Insertion sort versus quick sort. Insertion sort and the quick sort are two popular sorting algorithms used in computer science. While insertion sorts is a simple algorithm that works well on small data, The insertion sort is a simple algorithm that works on a small data. Quick sort is a more complex algorithm that is better suited for a large data set. The quick sort is more complex algorithm that is better than the suited for a large data set. Next, move to the next slide. Application of insertion sort. Insertion sort is commonly used in a small scale application where efficiency is not a primary component. It is not a primary component. For example, it can be used to sort a deck of cards or a list of games. It is used to sort a deck of cards or a list of names. In additionally to its use in a small scale application, insertion sort is also used in a large scale application such as database system and search engines. It is often used as a subroutines in more complex algorithm. It is used as a subroutines in more complex algorithm. Next, move to the next slide. Insertion sort implementation. To implement insertion sort in code, we need to follow a few simple steps. First, we need to take an unsorted array and initially a variable I to 1. First, we have to take an unsorted array, initially a variable I to 1. Then we start a loop that runs until I is less than the length of the array. The I should be less than the length of the array. Inside the loop, we initialize another variable j to 1 minus I minus 1. Next, we compare the value of at index I with the value at index j. We have to compare the index I with the value index j. If the value at index j is greater than the value at index I, we swap the two values. If the j is greater than the value of index I, we swap the two values. We continue this process moving j down the array until either the value at the index j is less than or equal to the value at index I or j reach 0. The value at the index j is less than or equal should be index of an I or a j when it's reached to be 0. Once we have found the correct position for the value at index I, we increment I and repeat the process until we have sorted the entire array. Let's move to the next slide. It's time to conclusion. What we have learned till now, we will see in this slide. In conclusion, we have learned about the concept of insertion sorts and its step-by-step process. We have also discussed its time complexity and compared it to the other sorting algorithms such as merge sorts and the quick sort. We have compared other such as merge sorts and the quick sort. Additionally, we have highlighted the advantage and the disadvantage of using insertion sorts as well as its real-world applications in various fields. It is important to understand insertion sorts as it is a fundamental algorithm used in computer science and programming. By understanding its strength and limitations, we can make informed decisions when choosing the appropriate sorting algorithm for our project. We encourage you to continue learning about sorting algorithm and their implementation to enhance your skills as a programmer. We encourage to continue the learning about the sorting algorithm and implementation of our skills as a programmer. Thank you for watching. This is Kailash Kumar signing off. Have a good day.